Hello everyone, welcome to the past paper discussion. In this video, we are going to discuss 8th question of this particular series. It is based on vectors. So two vector equation of two lines is given, and these two lines intersect at point M. We have to find the coordinates of the point M, also the acute angles between them. Let's go with the coordinates of the point M. A vector equation, they already simplified and combined it. So directly we can go for the components of the vectors. R vector can be represented at, you know that, right? R vector is xi, yj, zk, or R vector is in our form xyz. So both represent xyz. Now we can go with this. xyz, L1 says equals 3p plus 4 by 2p minus 1 by p plus 9. In the same way, we can see that another xyz here we can see it is equated to something related with q. Right? And now let's find out some equations on x, y, and z. It's quite simple. X is equal to 3p plus 4. And here x is equal to q minus 2. We can just equate them. So 3p plus 4 equal q minus 2. Let's simplify 3p minus q equals, like taking x as a subject, and then minus 2 minus 4, it's going to be minus 6. I got an equation. I have two variables. I'm looking for p and q, but we will get three different equations. And it is important here to use all three. Next one, y. Taking y, 2p minus 1 equal 1 minus q. 2p plus q equal, there is a positive one. When you shift it, it's a minus 1, so it will go 2. We got the second. So simultaneous equation in terms of PQ, but three equations. So next z part, this is also important. P plus 9 equal 2Q plus 1. So the respective components, and then P minus 2Q equal 1 minus 9, and it will go like minus 8. Got it? Now, using our GDC, you take any two of the equations, okay, and one equation we won't take because only two variables, so two equation is enough. And the third one, we will be using it further. First, let's simplify using our calculator part. And switching to the calculator now. Okay, here we go. So take your calculate and go for number and algebra. Then solve system of linear equations. We are dealing with two equations, so it is automatically with two variables, and click OK. So what are the two equations? In x and y you can give. There we have seen these kind of equations. Let me write it over here. Three different equations. I'm going to take the first and the last. Okay. So 3p minus q, but I'm going to take p as x. 3x minus y equals minus 6. Then second equation is x minus 2q. 2q means y actually. 2y equal negative 8. So be careful with that. That's it. And then we can just click enter. We got these values. And taking it over, wait, the solution page, we got p and q, correct? Now, let me switch to the solution page now. Fine. So minus, what is x? X is actually my p value, minus 4 by 5. And 18 by 5 is q value. You can convert to decimal also. And we will get 0.8 and 3.6. So these are PQ. Negative 0.8 and then 3.6. Fine. Now I need to find x, y, and z. Correct? So x is what? Any x, y, z you can take because it's a point of intersection, right? By any one of the component you can pick. The last one, this blue one seems to be fine, the L2 equation. So I'm going to take it. Q minus 2, 1 minus Q. And then it is 2Q plus 1. We know the values and we can just start substituting it. 3.6 is what we got, right? So 3.6 minus 2, 1 minus 3.6, 3.6 times 2 plus 1, which is going to be 1.6 minus 2.6. Here it's 8.2. So the coordinates of M are respectively 1.6, negative 2.6, and 8.2. That's simple. So we have completed the stuff here and moving forward to the next part. Next one. Find the acute angle between the two lines, and this acute angle formula, we have it in our formula booklet. An acute angle between two vectors is cos theta is. Some of you might have learned in that way, so don't get confused. Mostly you won't refer it if we have practiced a lot, right? So v vector dot w vector. So the two vectors you have to dot product it and divide it by modulus of those values. That is, you might have learned in that way also. No need to confuse. Whichever way you learned, go with that. And just for a reference, modulus of the vector is this. Like each component, you need to square and sum and then square root it. Got it? Right. And what is my V and W? This is line L1 and L2. Let's go. Okay. What is this V1, V2, V3? Actually, I got 3P plus something. In that way we have, right? Also, we got the P values. So here, before substituting it, we need to understand what is vector equation of the line. Vector equation of the line will look like this. R vector is A vector plus lambda B vector. A vector is a fixed point and B vector is the direction vector. And in this cos theta, like angle between the two lines, we will not depend upon the fixed point. It is based on the direction vector. So we need to fetch the direction vector here, right? And going back to the R vector, and let's see how to separate in that form, like fixed point plus this form. Let me take these two. Let's paste it here. Okay, this is important. Don't just substitute P and Q and make it stuff like that. Fine. So first one, L1, you can represent it R vector equal to fixed points. Can you see these? 4 minus 1 plus 9. So yeah, let's just use that. That's the fixed point. And plus a scalar times another kind of a vector. So P, if you take common, 3, 2, 1. Similarly, we should do the same for L2 also. Here you should be careful. So first fixed point is going to be minus 2, positive 1, positive 1. Okay, L2 R vector equals minus 2, positive 1, positive 1 plus Q times coefficients of Q. First is 1, second is minus 1, third coefficient is 2. So 1 minus 1, positive 2. This is important. And in the angle formula, we're going to use this direction vector, not the fixed point. That's why this is important. Hope it is clear. Let's move. Okay, so what is cos theta? This is my direction vectors, 3, 2, 1, and another direction vector. Let me take this as V, and this is W. You can take it in your own way too. And cos theta is, from our formula booklet, it says like V1 W1 plus V2 W2 plus V3 W3. This is nothing but the dot product divided by modulus V times modulus W. And we can further go like, what is this? Is your V1. First component, second component, third component of the vector. Same with this. Okay. And modulus V and W, let's find it over here. Modulus of V is square root of 3 square plus 2 square plus 1 square. These are simple calculations, so I'm not showing the calculator now. 3 square is 9, 1 square is 1, 9 plus 1 is 10, 10 plus 4 is 14, root 14. And what is modulus of W? Same and same process. 1 square plus minus 2 square plus 2 square. Hope I'm correct. See, I did a mistake. 1 square and it is like minus 1. When I'm copying it, I made an error. Right. So 1 square minus 1 square plus 2 square, and it is going to be square root of 2 plus 4. It's going to be 6. Right. So we got it, and the dot product is only thing pending over here. Let me copy this. Let's move it to the next page. Okay, here we go. How will you find V1, W1, V2, W2? So like this. 3 times 1, 2 times minus 1, 1 times 2. That is the dot product, right? So it will go 3 times 1 plus 2 times minus 1 plus 1 times 2. Divided by, we have the modulus of V root 14, modulus of V root 6 and cos theta. Okay, what is our range? Theta, angle, right? We can simplify it further. 3 minus 2 plus 2 by root 14 times root 16. And simplifying it, you got this. Cos theta equal 3 by root 14 root 6. Not 16, 6. And let's just take up this. What is theta? Cos inverse of it. And we can take the help of the calculator here. Moving to the calculator page. Okay, what I'm gonna do here. Yeah, same. We can go with algebra. Numerical solve. Cos theta equal. So let me treat it as theta as x here equals. I got some fraction, right? So the fraction is 3 over square root of 14, then outside times square root of 6. And I'm looking for solving x. Okay, so comma and then x. That's it. We got 70.894 because I placed it in, I just used the degree mode here. Yeah, you can choose radian and also both are accepted and change it to radian. Let me click enter, and this is the radian answer, right? Let's take it over there. And moving to the solution page. This is what we got, right? So don't interpret in such a way that relates with our question. Theta is equal to 70.9 degrees or theta equal 1.24 radians, right? This completes the problem over here. I hope this might be useful to you. Keep learning. Let's meet in the next video. Thank you so much for